We will be discussing in this lecture properties of Fourier representation. Fourier representation means Fourier transform, Fourier series, discrete Fourier transform, discrete Fourier series, discrete time Fourier series, all of them. Okay? Now, so there are four representations generally in Fourier representation. There are four different representations, and all four Fourier representations involve linear operations. Linear operations. So this property basically, this property is property number one, which is linearity property and symmetry property. Symmetry property. So this is property number one. Okay. So all Fourier representations involve linear operations. Linear operations. Hence satisfy linearity. Linearity property. Okay. So what does that mean? See, if I have a signal z of t, it is in time domain, and it is equal to a times x of t plus b times y of t. So we have a signal like z of t. It is made up of two different parts, x of t into a times x of t, and b times y of t, where a and b, they are both constants. X and t and t, y of t and x of t, they are two different signals which together they form z of t. So if we take Fourier transform of this, if we take Fourier transform of this, so we will have z of t, the Fourier transform of z of t will be z of j omega, like the Fourier transform of x of t is x of j omega. So z of t, its Fourier transform will be equal to z of j omega, and it is equal to a times x of t, its Fourier transform will be x of j omega plus b times y of j omega. Okay, so that is the first thing. The second thing that we have another signal, say for example Fourier series signal. So we have a signal z of t, which is equal to, in time domain, a times x of t plus b times y of t. So it is time domain, in time domain. If we want to take the Fourier series of this signal, so x of t, Fourier series of x of t will have, is having x of k. Okay, it is represented by x of k. So we will have z of t will become z of k, which is equal to a times the Fourier series of x of t is x of k plus b times y of k. That is one thing. Okay. Now, say for example, we have a discrete time signal z of n, discrete time signal z of n, and it is equal to a times x of n plus b times y of n. I am trying to represent four different Fourier representations. One in Fourier transform form, another in Fourier series form. The third one I'll show, it will be in discrete time Fourier transform form, then discrete time Fourier series form. Okay, so this is a discrete signal. What will be this discrete time Fourier transform? Discrete time Fourier transform. It's discrete time Fourier transform. We know Fourier transform of x of n is x of e raised to power j omega. So it will be z of e raised to power j omega. E raised to power j omega will be equal to a times x of e raised to power j omega, e raised to power j omega, plus b times y of e raised to power j omega. Okay. So fourth form and the last form, if we have a discrete time signal z of n equal to a times x of n plus b times y of n, then it's discrete time Fourier series, discrete time Fourier series can be written as z of k equal to a times x of k plus b times y of k. Okay, y of k. Now see, in our textbook, Simon Huygens, it mentions an example based on this Fourier series. Okay, it mentions an example based on Fourier series. So I will not deal that example. You will go through that example yourself. I'll show you an example that will be based on discrete time Fourier transform. Discrete time Fourier transform. Fourier series example is mentioned in the book. I will not copy paste it. I'll show you another example that is not mentioned in the book. Okay. So example on discrete time Fourier transform. Okay. So discrete time Fourier transform is the third example. So in third example, we have z of n, which is equal to a times, you have x of n and y of n. I will change it. I will call it x1 of n. That will be a different signal, plus b times x2 of n. Okay. तो हमारे पास थी b times y of n. So I'm not representing different signals now in terms of x and y. I'm representing in terms of x1 and x2. That is not difficult. So it's discrete time Fourier transform. Discrete time Fourier transform will be equal to z of e raised power j omega. Z of e raised power j omega. From third line, okay, third example, what will be it equal to? Rizwan, can you please help me in writing it? Z of e raised power j omega. Rizwan, roll number 27.
Ji sir, it will be a times
A times
x1 of e to power j omega
x1 of e to power j omega
plus b
plus,
times x2 of e to power minus j omega.
very correct. Okay. So e to power j omega. Okay, that will be discrete time Fourier transform. Where we know that where a and b are constants. Okay, they are nothing but they are constants. A and b are constants. Okay, so we know that discrete time Fourier transform of z of n, it is nothing but z of e to power j omega, e to power j omega, and that is equal to what? Summation of n equal to minus infinity to plus infinity z of n e to power minus j omega n. This is the general form. Okay, this is the general form we have already discussed in our previous lectures. So therefore we can write, therefore we have from equation, say for example this is equation 1. Okay, from equation 1, therefore we have from equation 1 we can write down then z of e raised power j omega will be equal to summation of okay, uh, summation from n equal to minus infinity to plus infinity. Then we had z of n here. Okay, we have z of n here. And what is our z of n? A x1 n plus b x2 n. Okay, a x1 n plus b x2 n. So I'll write down here a x1 of n plus b x2 of n. So that will be z of n. Then we have e raised power minus j omega n. Okay. So if we will further simplify it, we can write it in this form. It will be equal to summation equal to minus infinity n equal to minus infinity to plus infinity. Then a x1 of n e raised power minus j omega n plus summation n equal to minus infinity to plus infinity. Then b x2 of n e raised to power minus j omega n. Okay, and we can finally write it down a times, this is all x1 of e raised to power e to power j omega. Okay, so it is, this will be final, then finally it will boil down to a times x1 of e to the power ej omega plus, what is this thing, this is b times x2 of e raised power j omega. Okay, so that is same as equation 1. तो equation 1 में हमें मिला. Thus we can say that thus the output is linearly related and follows principle of superposition. Principle of superposition. ठीक है? So you can see once we have calculated the discrete time Fourier transform, we saw that output is linearly related. So it follows the linearity property. It follows the linearity property. And it also follows the principle of superposition. It also follows the principle of superposition. So whenever there is a linear relationship, it always follow a principle of superposition. The second portion is symmetry property. Okay, symmetry property. यहाँ तक समझ में आया? किसी बच्चे को कोई क्वेश्चन तो नहीं है? Hamad, do you have any question?
No, sir.
महविश को कोई सवाल तो नहीं है बेटा?
नो सर.
ठीक है, ओके. आपको महविश वो समझ में आया जो मैंने पहले कहा?
जी सर जी.
Okay. Now we have symmetry property. Okay. Symmetry properties. Symmetry properties, and these symmetry properties, they are in context through real and imaginary numbers. Real and imaginary forms. Okay. Now see, for symmetry properties, we will use Fourier transform to develop the symmetry properties. Okay, so we'll use Fourier transform to develop the symmetry properties. Now if we consider a signal x of j omega, which is basically Fourier transform of x of t, x of j omega, then it is equal to minus infinity to plus infinity. This is the general equation. Okay, x of t e raised to power minus j omega t dt. So this is the general equation of finding the Fourier transform of x of t. So we used to write it down in our previous lectures. Now for this equation, if we take a conjugate of this, okay, suppose we assume that we can write down x conjugate, x star of j omega will be equal to same signal here, okay, x of t e raised to power minus j omega t dt. But the only thing what I want is that I have to take the conjugate of it. Okay, so x conjugate of j omega will be equal to, left side conjugate will be equal to, if we take the conjugate of right hand side. Okay, so how we will take the conjugate of right hand side? We know that if we have a number a plus iota b, yeah, jb, its conjugate will be equal to a minus jb. The only thing you have to do, you have to change the sign of the imaginary part or complex, in complex number, imaginary part जो है इसका, real and imaginary part. So you have to change the sign of the imaginary part in the complex number, then you will be able to find the conjugate of complex conjugate of the number. Okay, so how we will find the complex conjugate of this number? Here we'll be able to find it like this. So you will have, just a second, same thing, integral minus infinity to plus infinity we don't know whether x of t is real or complex. Okay, we don't know whether it's a complex number or it's a real number. So let us try to find, let us assume that we have to still find its conjugate. So it will be equal to xt conjugate. ठीक है, इसका xt का conjugate will be x conjugate t, x star t. We have not elaborated it right now. Let us go to the next part, because next part has an imaginary part. It has j inside, e to power j omega t minus j omega t. Okay, so it was e to power minus j omega t. Now minus j will be replaced by minus j. Okay, j will be replaced by minus j, because we have to change the sign if we want to change it into conjugate form. Then you have omega t. Then we have omega t, and then you have dt here. Okay, so this is how we will change it into the conjugate form. Now the question is about, what about x of t? How do we represent x of t and its conjugate? If we suppose that x of t is real number, it's a real number. Okay, if it is a real number, then imaginary part of x of t, imaginary part of x of t will be equal to 0. Okay, in that case, when there will be no imaginary part, see, you have a plus j beta, and if this is a real number, then j beta is equal to 0 or b is equal to 0. So in that case the number will be equal to a. Okay, क्योंकि इसमें b नहीं है, there is no b, there is no imaginary part. So that is what I am saying here, that if we assume that number is real, x of t is real, then imaginary part of x of t is 0. If imaginary part of x of t is 0, then what do we conclude? X of t is then equal to x conjugate of t. Okay, x conjugate of t. So x conjugate अगर आप इसका ढूंढोगे, since there is no imaginary part, it will be x of t. What is the conjugate of a if there is no j beta? If there is no j beta, it is also a. It is same. A का तो conjugate a ही होगा, because इसमें imaginary part नहीं है. Similarly, I said x of t will be equal to x conjugate of t, because there is no imaginary part present in the number. Okay, now this is what we were able to conclude now. Substituting x of t equal to x conjugate of t in above equation. Okay, जो ऊपर है. Say for example, this is equation 1. In above equation 1. So what we will be having, we'll have x conjugate of j omega will be now equal to integral of minus infinity to plus infinity. Instead of x conjugate t, we will write down x of t. Okay, x of t. And we can write the same thing, x of minus j minus omega. Okay, t, then dt. This one, is it fine, beta? आपको समझ में आ रहा है?
जी सर.
What about Dinish? Dinish is here?
Yes, sir.
आपको बेटा समझ में आया?
जी सर.
हमाद?
Yes sir.
महविश को भी समझ में आया?
Yes, sir.
ठीक है, okay. Now see, this implies, which implies x conjugate j omega is nothing but it is equal to x of minus j omega. X of minus j omega. Okay. Now see, वो इसलिए मैं कह रहा हूँ because x of j omega, it is equal to, integral minus infinity to plus infinity x of t e raised to power minus j omega t dt. ठीक है, तो x of minus j omega किसके बराबर होगा? वहां omega will be replaced by minus omega. So what is the difference here between this and this? Omega is replaced by minus omega. So you have minus omega here also then. Okay, you will write down, it will be equal to it will be equal to minus infinity to plus infinity x of t e raised for minus j omega तो अपना ही है. Instead of omega you have to write down minus omega of t dt, and that would resemble uh, this equation. Okay, that would resemble this equation. So that is why I said x conjugate of j omega is equal to x of minus j omega, x of minus j omega, x of minus j omega. So this is the conclusion now. Okay, this is the conclusion now. Now we can say then, thus x of j omega is a complex conjugate. It is a complex conjugate symmetric. Okay, it's a complex conjugate symmetric. Yani it means that it has a complex conjugate symmetry. We have already discussed what does a complex conjugate symmetry means, or we can say the same thing, x of conjugate of j omega, x of j omega is equal to x of minus j omega. That is what complex conjugate symmetry would mean. Okay, and if we take real and complex, real and imaginary parts of this expression, so taking real and imaginary parts of this expression, real and imaginary parts of this expression will give us, okay, this comes from that concept complex conjugate symmetry. जब हम देखते हैं उसमें real part का अगर आपको याद है, real portion of the signal has even symmetry and odd and imaginary part has odd symmetry. तो ये हमने already discuss किया है. You will revise it from your previous lectures जो हमने class में already दिखाया है. Then we can, if we take real and imaginary parts of this expression, then we can write down real part of x of j omega. Okay, real part of x of j omega, it is equal to real part of x of minus j omega. What does that mean? That would mean that real part has even symmetry, or it is even function. Okay, it is even function. And what about imaginary part from this conclusion? From imaginary part of the expression x of j omega, it is equal to minus times, okay, it is equal to minus times imaginary part of x of minus j omega. And what does that mean? That means that imaginary part has an odd symmetry, or it is an odd function. It is an odd function. Okay, imaginary part is odd function, imaginary part has odd symmetry, and real part has even symmetry. Then only a complex signal, complex conjugate signal, is said to have a complex conjugate symmetry. Okay? Now see, if x of t is real valued, is it fine? Rizwan beta, ye theek hai?
जी सर.
Okay, what about others? I'll ask students. Umaid Parvez, roll number 62.
मेरा है.
उबैदा 69 जी.
यस सर.
हाँ बताइए क्या बोल रहे थे बेटा आप?
सर मैं बोल रही थी ये साइड से दिख ही नहीं रहा था कंप्लीटली, मैं यही बोल रही थी
अच्छा, दिस मच.
बस.
सुहेब बशीर 64, बेटा आपको समझ में आया?
यस सर.
ओके. So I can conclude now. Okay, I can conclude now. You can take a screenshot if somebody wants to take. Please take a screenshot, and so that I can write further. So I can conclude now, if x of t is real valued, that we have assumed, if it is real valued, then real part of the transform, real part of the transform is even function. Even function जो मैंने ऊपर किया है discuss. Okay, even function of what? Even function of frequency, because it is all function of frequency, while imaginary part is odd function of frequency. Okay, so we know that real part gives us magnitude spectrum, and phase spectrum is being given by the imaginary part, basically. So we can now write down, hence the magnitude spectrum. अगर आपने देखा होगा पिछले जब हमने पिछली बार भी लिखा बनाया था magnitude spectrum, it used to have even symmetry. और जो फेज स्पेक्ट्रम हमने बनाया था पिछले एग्जाम्पल्स में भी, उसमें ऑड सिमेट्री हुआ करती थी. इट इज बिकॉज ऑफ दिस. Okay, because x of t, if it is real value, so hence magnitude spectrum, we can say then, hence magnitude spectrum has even symmetry, and the phase spectrum has odd symmetry. आगे भी इस पे कहीं कहीं डिस्कशन होगा. Hence we can say the complex conjugate symmetry in the Fourier transform leads to a simple characterization of the output. Okay, of the output. I'll show you an example. ये थोड़ा सा clear हो जाएगा what I'm writing now. Output of an linear time invariant system. So hence the complex conjugate symmetry in Fourier transform leads to simple characterization of output of an linear time invariant system with a real valued impulse response. With a real valued impulse response. I'll show you an example. उससे थोड़ा ये clear हो जाएगा. The real valued impulse response when input is real valued. When input is real valued. When input is real valued sinusoid. Okay. So what does that mean? Let us assume that input is equal to, input signal is equal to x of t. X of t is equal to x of t is equal to cos of omega t minus phi. Okay, omega t minus phi. So this is equation 1, say for example, and the real valued impulse response, for example, impulse response be denoted by h of t. So impulse response is h of t. Your input signal is x of t equal to cos omega t minus phi. Okay. So then what is the Fourier transform of x of t? Fourier transform of h of t, h of t will be equal to, Fourier transform of h of t will be equal to h of j omega. Okay. So if we use Euler's formula, using Euler's formula on equation 1, we can write down that x of t in terms of Euler's formula, because it is a cos theta now. Okay, cos theta. So you know that cos theta, it is equal to 1/2 of e raised to power j theta plus e raised to power minus j theta. So I can write down like this. A is the amplitude. Okay, A is the amplitude. A. We can write down A also here. A is the amplitude. So A by 2, because it is 1/2 of A by 2, e raised to power j theta. So you have j, what is theta here? It is omega t minus phi. Then plus A by 2 e raised to power minus j theta minus omega t minus phi. This is the theta. Okay. Now we know we have already discussed linearity property. Linearity property. We can say then y of this is input. Okay, this is input. So our system is like this. So this is h of t here. You are applying an input x of t. Then you are obtaining an output y of t. We are obtaining an output y of t. So using linearity property now, using linearity property now, because we know we have two terms now. We have to assume the linearity property. One term is here, another term is here. So our x of t, which is basically input, it is made up of two different signals, two different exponential signals. One is e raised power e to the power plus j something, then it is second is e to the power minus j theta. So it is made up of two different terms. So we will use linearity property. That's why we'll use linearity property. So what is output then? Output will be equal to h of t into x of t. h of t into x of t. तो इसका Fourier transform जब हम निकालेंगे, it will be h of j omega. h of j omega that I have shown here at in this equation. So it will be equal to h of j omega instead of h of t, h of j omega, then a by 2. A by 2 is the amplitude, then e raised power plus j omega t minus phi plus will be the angle which will be changed by h of j omega. Okay, plus argument of h of j omega, argument of h of j omega. So that will be the first term. दूसरी टर्म क्या बनेगी? इट विल बी इक्वल टू प्लस a by 2 है ही वहां पे, लेकिन उसको जब मल्टीप्लाई होगा in terms of by h of t, impulse response जब उसका निकालेंगे, so it will be h of j omega, but it will be h of minus j omega. So it will be h of minus j omega. Then a by 2 e raised power minus j, you have omega t minus phi. Okay, then minus argument, because the angle here will be negative, you have minus j here, so minus argument of h of j omega. This is the second term. Say for example this is equation 2. We just need to derive a conclusion out of it. हमें इससे और कुछ नहीं करना है. So we don't need to, these exponential terms are not needed. We will just convert back them using Euler's formula. Okay. So we will exploit here, exploiting symmetry conditions. Symmetry conditions. Symmetry condition. Please turn off your mic. Symmetry conditions. Momin, अपनी mic बंद करो बेटा. Momin. Using symmetry, exploiting symmetry conditions, h of j omega, magnitude of h of j omega will be equal to magnitude of h of minus j omega. Magnitude of h of j omega will be equal to magnitude of minus j omega. Okay. So using symmetry conditions, then we will write down and argument h of j omega will be equal to minus argument of h of j omega. Okay, because the first term will give us amplitude spectrum. And we know for amplitude spectrum we have already discussed it that magnitude spectrum has even symmetry. Okay, magnitude spectrum h of j omega, if we'll plot it, it will give you magnitude spectrum. Magnitude spectrum has even symmetry. The angle that is present there, argument of something, angle will give us phase spectrum. Angle always gives us phase spectrum. So phase spectrum has odd symmetry. That is why I have said here, because this is because of magnitude spectrum. It can give us magnitude spectrum which has even function or even symmetry. This means angle. Angle always gives us phase spectrum. Phase spectrum. And phase spectrum has always an odd symmetry. Okay, that is why I have changed it like this. Now, if we will use Euler's formula again, using Euler's formula in equation 2. Equation 2 जो है, this is equation 2. Okay, this is equation second. It is in the form of exponential form. जैसे हमने यहाँ पे किया था. Okay. What we have done here, we used Euler's formula in equation 1. We changed it in the form of exponential terms. Now in equation 2 is also in exponential terms. We can use Euler's formula and change it back to the cos theta. Okay, change it back to the cos theta. So that is what I will do here. If we use Euler's formula in equation 1, we change its exponential terms in terms of its cos form, then we will have y of t. Y of t we will have first term will be h of j omega. H of j omega, because that is common to both. Okay, h of j omega is here. H of j omega is here in equation 2. It can come common, and because of even symmetry, we have concluded that h of j omega, it is equal to h of minus j omega. So we can take them common because it is one and the same thing. So it will be taken common. जो अंदर आपको बचेगा, it will be a by 2. A by 2, it will give you a times. Then you have cos of theta. Cos of theta. What is theta? Theta is omega t minus phi plus argument of h of j omega. H of j omega. Okay. So this is what we will be obtaining after we change it back to its cos form by using Euler's formula. So after obtaining this equation, we can now conclude that hence this system, which system? This system, okay? The system that I have shown here in the diagram. Hence the system, I have skipped many steps there. You can, write at your own place, you can write each step properly. I have skipped because otherwise it will take a lot of time. Hence this step, this system, it modifies our input. It modifies the amplitude of the signal by h of j omega, and phase by argument of h of j omega. Okay, so this system, if you will see what is different in equation this, see, we have an equation here. One equation is this one, another equation is this one. So first equation 1 is input signal. Y of t, equation 3 is your output signal. What is difference in input and output? The signal is basically modified. Okay, output may, you will see that the signal is modified. Its amplitude is modified by h of j omega, and its angle is also modified by argument of h of j omega. So phase is modified and its angle, its amplitude is also modified. If we plot these waves, अगर इसका amplitude पहले हम, let us see what is the input. So this is our system. This is our system h of t. So we have x of t here. Then we obtained h of y of t as an output. So how does x of t look like? X of t is probably like this. This is x of t. This is our x of t. What is the amplitude of input? Maximum amplitude is a. X of t, a cos omega t minus theta. Okay. So what is my input signal? Just a second. My input signal is x of t. X of t is equal to a cos of omega t minus phi, for example, minus phi. So what is the amplitude? Maximum amplitude is a. So you have maximum amplitude A. Okay. What is the phase difference? Cos theta. What is the ideal waveform of cos theta? Cos theta होना तो ऐसे चाहिए था. Cos theta should be basically like this. Okay. This is cos theta. It starts from here. Cos of 0 is equal to 1. Cos of 0 is equal to 1. So peak amplitude is at 0. लेकिन इसका peak amplitude 0 पे नहीं है. There is some phase difference. Okay. There is some phase difference. There is some phase difference. So how much is the phase difference of theta? See, what is theta here? This is theta. So if you will see theta, for example, is equal to 0, it means omega t minus phi, it is equal to 0. So if we calculate t out of this, तो जो आपका peak आएगा वो आएगा phi divided by omega पे. Phi divided by omega पे. Because you have to keep theta equal to 0, that is where the peak is basically. Should be, the peak should be. So you will be having here जो phase difference इसमें होगी वो होगी phi divided by omega. Phi divided by omega. और इसी तरीके से जो ये नीचे से है, नीचे से भी आपको minus a होगा. ऊपर से प्लस ए, नीचे से माइनस ए. दिस इज एक्स ऑफ टी. लेकिन जब हमने चेंज किया इसको, एक्स ऑफ टी को किया चेंज, वी पास्ड इट थ्रू द सिस्टम, वी हैव नाउ y of t. Okay, so y of t will be equal to this one. Is it fine?
Yes, sir.
बता दिया आपको बेटा, समझ में आया है x of t?
Yes, sir. Yes, sir.
हमाद बेटा आपको समझ में आया?
Yes, sir.
महविश?
Yes, sir.
What about Aruja?
Yes, sir.
Okay, ठीक है. तो अब हम इसको आउटपुट करेंगे. Okay, let us try to mark now output. So say for example the output is like this. Just a second. So the output is like this. It has more phase difference. It has more phase difference. It is also a cos wave, okay, but it has more phase difference. इसका period consistent होगा. I don't know what is इसमें मैंने थोड़ा सा सही स्मूथली नहीं बनाई है, but it is a cos wave and regular. इसका time period जितना भी होगा वो consistent होगा. So its amplitude here. What is the amplitude here in the output? It is a times h of j omega. Okay, amplitude should be a times h of j omega should be the amplitude. So इसी तरीके से नीचे से भी इसका होगा amplitude minus a times h of j omega. तो इसका amplitude जैसे यहाँ था plus a and minus a, similarly you will have amplitude this thing. And what should be the phase shift? Phase shift will be theta will be equal to 0. What is theta? Omega t minus phi plus argument of h of j omega should be equal to 0. Okay, so we have to calculate t here. Okay, we have to calculate t here. So it will be equal to omega t will be equal to phi minus argument of h of j omega. Okay, then t will be equal to phi minus argument of h of j omega divided by omega. Okay, so wherever there is a phase difference, so that phase difference will be equal to, we draw it using green now. Wherever there is a phase difference will be equal to phi minus argument of h of j omega divided by omega. That is where what is the phase difference in the signal, okay, or in this field form. Okay, all right. So this was linearity and symmetry property. Symmetry property. So we'll go for another property known as
सर आवाज नहीं आ रही है ना, स्क्रीन आ रहा है।
सर नेटवर्क इशू सर।
स्क्रीन आ रहा है मेरे को बट आवाज नहीं आ रही है सर की।
सर का डिवाइस
सर
हैंग हो
आज
गया।
इतने बंद।
क्लास खत्म हो गई क्या
नहीं
रिजवान? अब सर ने
सर,
लीव किया।
वो नए से ज्वाइन करेंगे। वेट करना है हमें।
सर का
सर
एक
हाँ हाँ
है
ऑब्वियसली
वर्चुअल
सर का एक डिवाइस ऑलरेडी कनेक्टेड है ना तो वेट कर लेते हैं।
रिजवान को बोलो सर को मैसेज करने के लिए।
हाँ कोई सर को मैसेज करो। रिजवान तुम कर लो।
सर खुद आएंगे। जरा वेट करो, तुम लोग क्यों।
मैंने टेक्स्ट किया सर।
ओके ओके।
करो लीव सर सच में।
वेट ना, करता है ना वेट
हाँ,
कुछ
वेट
टाइम।
हो गया है, टाइम हो गया खत्म बहुत।
सर ऑलरेडी है ना सर के यहाँ पे एक डिवाइस
कहाँ है
कनेक्टेड।
सर? तो पढ़ा था ना वो।
सर ठीक नहीं यहाँ पे
है
तो।
ना एन एक
एक
आने दो ना
डिवाइस है
रिजवान को टेस्ट
कनेक्टेड, एक
की।
डिवाइस है
एक
कनेक्टेड।
डिवाइस है कनेक्टेड, मे बी सर को
अब
नेटवर्क
उनका
इशू होगा, सबर
अब हो
रखो
गया ना
ना।
टाइम।
अब क्या रखूं?
चेक करो बैठो।
वेट वेट, रिजवान को मैसेज की ना सर ने, देखते हैं क्या बोलते हैं सर। रिजवान सर ने रिप्लाई दिया।
ना।
फोन करो सर को।
जरा सब्र रखो।
अच्छा छोड़ो, मैं ही करती हूँ, रुको वेट करो।
अब हो गया टाइम। लेट्स लीव नाउ। तो वैसे भी एक
नहीं
होगा।
नहीं नहीं, मैंने सर को फोन किया, एक सेकंड एक सेकंड, सर ने बोला मेरा डिस्कनेक्टेड हो गया, आई एम कनेक्टिंग अगेन।
जी आपको आवाज आ रही है?
यस
यस
सर
सर,
आ
आप आ
रही
रही
है।
Just a second, I got unfortunately disconnected. I'll just conclude. Give me 2 minutes and
ओके सर।
I'll join again. Just a second. FU dash TH. Rizwan, can you hear me now?
Yes, sir.
What was the last thing you have heard?
Sir, phase difference.
Phase difference?
Phase difference.
Periodicity आपने बिल्कुल नहीं देखी थी?
No, sir.
Okay, ठीक है. All right. So periodicity is the next thing that I wanted to discuss. Okay, I have written quite many things. Okay. Now see, discrete time Fourier transform, they have a period. They are always periodic in omega with a period of 2 pi. ठीक है? चाहे
सर आवाज नहीं आ रही है।
आवाज नहीं आ रही है?
No, sir.
Just a second. Okay, okay. Give me a second. Is it fine now?
Yes, sir.
Okay. Now, see what I said, that I said in order to discuss the periodicity property of these Fourier representations, I said discrete time Fourier transform is always periodic in omega with a period of 2 pi. Generally, sinusoidal signals हो या Euler's जो भी है, ये periodic
सर
होती हैं.
आवाज ही साफ नहीं आ रही है।
सबको ऐसे ही आ रही है?
Yes, sir.
सर कट रही है आवाज।
आपकी आवाज कट कट के आ रही है।
Okay, okay. Give me a second. I'll log out and I'll join once more.
सर कल करते हैं आप कंटिन्यू।
सर अब कल पढ़ते हैं।
अब ठीक आ रही है?
सर ये सर आवाज ठीक है सर, हम कल कंटिन्यू करें, इट्स नमाज टाइम नाउ।
Okay, I'll do one thing. I'll make a video for this property. आप फिर उसके बाद वो खुद देख लेना. एक दो properties और है. आप उसको कुछ चीजें मैं आप पे रखूंगा, कुछ चीजें मैं खुद. There are more than 10-15 properties of Fourier transform. एक दो मैं आज करूंगा, दो तीन next video में, maybe couple of lectures for Fourier transform properties. Then we'll wind up. ठीक है?
Okay,
So,
sir.
okay, we'll stop now. I'll stop now. No problem. ठीक है.
ओके सर।